I have a beehive with multiple cameras inside and outside for observation. These cameras are operated by a single Raspberry Pi. I use ChromeTab to take short video clips every couple minutes. Now, the problem is I want to see video clips with something interesting in it, and most of the time it's quite boring. The outside of my hive looks like this. Not very busy or interesting to look at. I'd like to get a clip that looks more like this, but automatically. Well, luckily there is a customizable Python package. Here's the website I found that inspired me to create such a program. This article was written by Alan B., also the author of the detecto Python package. In this short article, he shows how easy it is to install and customize a image recognizing AI to identify and label images. The instructions seemed benign enough. Just install the package, customize your own dataset with an executable called label image, and then train the custom model, and then use this model to label an unknown image. So I jumped over to GitHub and I downloaded the detecto package. I tried to install it using pip, and after a lot of trial and error, eventually I got it somehow. It wouldn't install in this normal way here. I think it was because I was running as the user and not the admin, and I had some trouble with different environments on Anaconda, so I had to stick with the default root environment. I had to uninstall and reinstall Anaconda several times because I think I had it corrupted at some point. I also had to manually install PyTorch in this fashion with these settings to make sure that it works with my GPU. To label the images, first I wrote a script on the Jupyter Notebook to extract random frames out of each of my video clips of the entrance of the hive. This script takes about 100 random video clips and then takes one random frame out of each clip, then saves it as a JPEG. You can see here that it's reading the directory and randomizing it here, and then taking the first 100 video files. Then it runs through this for loop and it extracts a random frame and then saves it as a frame JPEG in a folder. I then go to the label image program and I begin to manually place a box called B around the actual insect and then a box called P around the pollen in the bee's leg. I may eventually want to detect how much pollen is coming into the hive, but this video will not be addressing that, so you can ignore the P box. The reason for taking small samples from many random video clips is because the sunlight changes the image in a way depending on the time of the day. This will broaden the way the program will detect the bees. So now I have all the images and annotations under one directory called the out directory, and it's time to train detecto. I also make sure that CUDA is available because it takes forever to process an image with a CPU. I then save the model to a file called modelweights.pth for later usage, and in this cell I open up the file and run a test on it with a random JPEG file of the bee entrance. It does detect the bees, but it also has some false positive, like these things in the background that is just some cloth in the back. But luckily it also indicates the probability, which is pretty low, and so we can throw at those ones and just look for the ones that the program is confident in. So now that we know the program can detect bees from a single frame from a video, we need to modify it so that it can count the number of bees from the entire video file. I tried using the detect video procedure provided with the detecto package, but it couldn't read my video file, so I had to write my own. So here is my program. First, we specify the directory containing all the video files, and this contains the latest video files from my Raspberry Pi. I also specify the number of frames to skip, because even with CUDA it takes too long to process each video clip. I recall the model that we trained, and then I start gathering the files. Here we see that I go to that video directory and I look for the video files with the extension of AVI or MP4. Then I select only the files from the camera at the entrance called out. Then I get the latest file by using the getMtime. So the video file now is the last video file that was recording the entrance of the hive. Here I load up the video clip using OpenCV, which works pretty well. I then run through the clip and go to each fifth frame, and then I use the detecto predict method to look at the individual frame and gather all the labels, the position, which is called boxes, and finally the confidence score. I then filter the score using this custom function called filter score, which is all the way up here, and I take only the scores that are greater than 70% confidence. And then I save it as a figure. The myShowLabelImage function takes the images and draws a box around them. It is basically the same as the one within detecto, except I wanted to get rid of the tick boxes and access labels. Then I take that figure all the way which is from the matplotlib package, and convert it to a numpy form. I don't know how to combine matplot figures into a movie, but I do know how to use OpenCV to make movies out of single images. OpenCV by default recognizes numpy objects. So here's the movie in action. It's sped up because it only takes and processes only the fifth frame out of each clip. Now that the program can reliably label each bee in each frame, we take the number of bees per frame and append it to a list called beelog over here. And then we can run some statistics on the beelog and find the maximum number of bees in each video clip and the mean, median, and mode. I find that a good score to know when to record is to combine the average, median, and mode, but the max number of bees in each clip is also fairly accurate. And then I save all that data into a CSV file. This CSV file is a log of each entrance video and the number of bees associated with them. Here is what that file looks like. We keep track of the number of seconds, the maximum number of bees in each clip, the average, median, and mode here, and put it into this giant graph here. The timing is a little bit messed up because Excel doesn't recognize Python times. So here we can see that anything that's over a 10 usually means there's a lot of bees in front of that hive entrance. I originally thought I could run detecto on Raspberry Pi, but I couldn't even get Torch to install on it, and it would probably take forever to process each video clip on such a low-powered device. So here's my solution. Every 10 minutes, the Raspberry Pi would automatically take a video of the hive entrance using crontab. Then my Windows workstation would sync with the Raspberry Pi folder every 10 minutes and get the latest video. Once the video is downloaded, the detecto program counts the number of bees and stores it on a spreadsheet. That spreadsheet is uploaded to Raspberry Pi, and then a watchdog program on the Raspberry Pi reads that spreadsheet and decides if it should record another entrance video. All of this must occur within 10 minutes or the Raspberry Pi will try to record off of 2 cameras and bad things will happen. Since I'm using Windows, there's no native crontab, and I don't want to run some Linux program just to sync files up. I found that WinSCP works across many platforms, and I like how easy it is to use. I found that WinSCP actually provides sample PowerShell script files to customize the syncing. Then the script will start a WinSCP session. I specify that it should look for certain files to sync, including the out entrance video files and the count, which is the spreadsheet containing the number of bees. Then if actual files were downloaded, we detect the change, and then we execute the detecto script. It took me a while, but I found out that due to user permission settings on Windows, I could not execute a Python script as a PowerShell user. I had to run Python from Conda and specify to use the base environment. After the detecto script was finished, another WinSCP synchronization is executed to upload that spreadsheet. Assuming that there will be a new video on Raspberry Pi, every 10 minutes this PowerShell script should repeat itself. But because the detecto script and downloading the video takes a variable amount of time, it can't be executed every 10 minutes. So I need to get the time in minutes, then calculate how long it is to wait until it is about 2 minutes after every 10 minutes. Here is how I did my calculations. And then every 2 minutes is used because it's enough time for the entrance video to be recorded. Over at the Raspberry Pi, there's a script that looks for the spreadsheet file that gets modified. I use a package called Watchdog. This Watchdog program would observe the spreadsheet file, which is specified in the target variable. If there is a dispatched event detected by Watchdog, it executes this procedure here, and it determines if the event type is relevant. Anything like reading or opening the file can trigger an event, so we want to know if the spreadsheet was updated, and the closest event that I could find was called the event type close type. Once the file change has been detected, the time is noted, and if the time is too close to the 10-minute mark, the program will abort because recording at that moment may cause multiple cameras to also record at the same time. Once the file change has been detected, the time is noted. If the time is too close to the 10-minute mark, the program will abort because recording at that moment may cause multiple cameras to also record at the same time. Then the spreadsheet is opened using Pandas and the last row is checked. The time is recorded in the last row, so it must be also within the last 10 minutes in which this Watchdog program detected a file change. This is to prevent relying on old irrelevant data in case the file was opened or saved without adding new information. The cell that is used is the second column of the last row of the spreadsheet, which is the average and mode and medium. Then, if that number is 10 or above, we run a bash script which tells the Raspberry Pi to record using the entrance camera. The program has worked pretty well. Now I can enjoy watching many bees. All it took was many tears and hours of my life.